Okay, so this is 2.2. It's more about quadratic functions. We're going to talk about the anatomy of a quadratic function. There's two possible forms. A quadratic function can be represented in one of two forms. We first have standard form, which looks like this. Function of x equals a times x minus h squared plus k. This form is handy because it allows you to use your transformations that you learned in 1.6 to make its graph. The values of h and k represent the vertex of the parabola. Okay, so think of this on from 1.6. This might be a reflection or stretch or shrink. Inside here, this shifts it left or right. Okay, again, if it's a minus, it's going to shift it to the right. If it's a plus, it's going to shift it to the left. This here shifts it up and down. Okay, so that's just kind of a review from 1.6. General form, which is honestly the way I like it better, but both of them I'm fine with. I just kind of like this one better because this is how I was taught. It's not as handy as standard form. Only real perk is that you can get the y-intercept easily by plugging in 0 for x, because this is going to become 0, so is this. So your y-intercept is going to be a constant. Okay, so it would be 0 in whatever c is. Notice in both forms the value a is the same. Okay, and it's real important that you understand that part, because here's what they talk about. If a is greater than 0, the parabola opens up from the vertex. So basically what they're saying is if a is positive, your parabola is going to look like this. It opens up. Positive people bring you up. This here, if a is less than 0, that means if a is negative, your parabola is going to open down like this. Okay, negative people bring you down. Those are pretty bad parabolas, but pretend like they're good. Right, the graph of the parabola is always symmetric on each side of its vertex. Okay, which is kind of nice. The vertical line through the vertex is called the axis of symmetry. So here's your vertex here. It used to be called, it could be called a minimum. But anytime we're going to start working on word problems, when you see minimum or maximum, you're going to think vertex. Okay, it's the same thing. This would be a minimum or the vertex. This would be a maximum or the vertex. Okay, notice there's an axis of symmetry. That is an imaginary line that this left side is equal to the right side. Okay, and it's always at x equals h. That's how you do a vertical line. Now that h is going to be a number. It might be h equals 3. That is the equation of the axis of symmetry. Because again, the axis of symmetry is a line. It's an imaginary vertical line. And vertical lines are represented in x equals some constant. Okay, right here, same thing. Your axis of symmetry is going to be x equals whatever your h is. And this here, notice it opens down. The left, if you folded it along this, all these points would lay on top of those. They're symmetric. Okay, so now we're going to use this thing. Okay, first thing we're going to talk about is standard form. Okay, again, this here is best for graphing using your 1.6 techniques. All right, this is standard form. Now the thing you have to be really careful about is when finding the vertex is right here. This looks like a negative one, but because of the formula being a minus, the x value is going to be 1. So I think of it as a sign change. That may or may not work for you. I don't know. That's just how I think about it. Sorry, my phone went off. Of a sign change. This one though, however, because that's a plus sign, this just, whatever it looks like it is. This looks like a -8. So my vertex is at 1, -8. So this stays the same. Okay. All right. Now let's talk about, so 1, -8. Let's go ahead and graph it. You're going to go right 1, down 8. I'm going to put that in a black. Let's do that in red. Right 1, down 8. It's right here. That's my vertex. Notice A is positive. That's going to tell us that it's going to open up. Okay. Now, from 1.6, this is going to stretch by a factor of 2. And it's going to stretch it vertically. Okay. This here is going to move it right 1, down 8. Now notice, you remember our x squared, okay, this is the x squared. It starts here and it goes up like this. Well, notice, it was at 0, 0. It moved right 1, down 8, okay? Now, because if I knew these transformations, this is how fast I can graph it. Well, my x squared, usually it would be right 1, up 1. Because of this 2 here, the stretch factor of 2, instead of going right 1, up 1, you're going to go right 1, up 2. The next one would really be right 2, up 4, but because of this stretch factor of 4, you're going to go up 8. Right here. And then it's usually right 3, up 9, so it would be going up 18. Okay, now, because of the axis of symmetry that I talked about before, there's this imaginary line right here. Okay, and let's go ahead and write that as a line. It is at x equals, this vertex, remember, was at 1, -8. So this imaginary line has the formula of x equals 1. It's the same thing as this. Now, why is this so important? Here's why. If you can figure out this point here, it is 1 unit to the right of that axis, then there's a point right here because it's symmetric, 1 to the left. Here is that axis of symmetry. You have a point 2 to the right. You're going to have 1, 2 to the left. And now you can draw your parabola. A parabola is a curve. Do not just connect the points like in straight lines, because it's a curve. It's not the best in the world, but it'll work. Okay, so now the domain, we don't have to worry about anything because we're not taking the square root of a negative number, not dividing by 0. So our domain is all real numbers. There's no x values that we're not going to use. Okay, we use all of these and we use all of these. Our range, however, is down here to -8. The lowest point is -8, but it goes to infinity. This is a bracket because there's actually a point that's included at -8 and it goes to positive infinity. Now the x-intercept's really easy to see because they were actually points of the parabola. So the x-intercepts what on this one right here was 1, 2, 3, so it was 3, 0, and over here was negative 1, 0. Now, sometimes though, it's not so clean. They might be between two of the lines, okay? They may not be so clean like 3 and negative 1. So you've already learned how to find x-intercepts. Right now, you'll notice that every x-intercept has a y of 0. So what you do is you take your function and you substitute, let's try this again. You set y equal to 0, and then you solve for x. So you would say 0, and you would take your function up here, right here, okay, 2 parentheses x minus 1 squared minus 8. Now there's different ways of working this problem, but the fastest way is to do this. I'm going to use a square root property. So I'm going to add 8 to both sides. I get 8 equals 2 times x minus 1 squared. Now I'm going to divide both sides by 2 because I can't take the square root property until I get this squared part by itself. I get 4 equals x minus 1 squared. Now, if I take the square root of both sides, this square and square root cancel each other out. But what I do to one side, I do to the other. Now, you've got to be careful here. This square root symbol was not in our original problem. So that means we're going to take a positive and negative 2. Over here, I'm left with x minus 1. So now I'm going to add 1 to both sides. And I'm going to get 2 answers. I'm going to get 1 plus 2 and 1 minus 2. So I'm just going to do it like this. 1 plus 2, which gives me 3. And then I'm going to do 1 minus 2, which gives me negative 1. So those are the 2 points. When y is 0, x will be 3, and negative 1, 0. Those were my x-intercepts. Now, why did I do all that? I didn't have to on this problem, but the next problems we're going to have to do that. Now, the y-intercept, to find it, you set your x equal to 0. Okay, so what I am doing is I'm taking my function f and I'm plugging in 0 wherever I see x. Okay, so I plugged a 0 in right here because that's where my x was, right here. Okay, now I just solve. Right here I'm going to have 2 times, this gives me negative 1 squared minus 8. Well, this is going to give me a positive 1, so I have 2 times 1 minus 8. I'm going to multiply before I subtract, so I get 2 minus 8, which gives me negative 6. This is my y-intercept. Intercepts are points, so if I ask for an ordered pair, you would put 0, negative 6. And you'll notice 0, 1, 2, 3, 4, 5, 6. Now, we didn't have to do all this work for this particular problem because we could have looked at the graph and just found the x-intercept and y-intercept. But trust me, they're not going to be like that always, okay? So, let's go to the next one. This one right here. Okay, this is going to, because of this, it's going to open down. Which means it reflected about the x-axis, okay? So, that's all that means, the same thing. Right here, you have a shrink factor of 1/2. That means it's going to shrink the y, Okay. All right, so this here, it's inside the function, so it's going to move left 3. Right here, it's going to move up 8. Okay, so this is in vertex form, or actually in my other class they call it vertex form. They call it standard form, right? It's weird because in my other class, the other way is standard form, but oh well. Okay, vertex, remember it's a sign change here. So this looks like a positive 3, it's going to be a negative 3. That looks like an 8, it's going to stay an 8. So there's our vertex. We're going to go left 3, 1, 2, 3, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there was my shifting left and up 8. Okay. We know it's going to open down, so it's going to open this way. Okay. Usually what happens is it's usually the original one would be down 1, right 1, I'm sorry, let's try that again. Right 1, down 1, because usually it's right 1, up 1, but remember we have a reflection. Then it's right 2, down 4. 1, 2, 3, 4. Then it's right 3, down 9. This would be 8, 9 right here. Okay. Don't forget, you have this axis of symmetry. That is an imaginary line, vertical line at x equals -3. Okay, it's on the -3. That is that line. Now the reason you need that is the original one. We haven't done any of this. We haven't done this part yet. The original one, which is an x squared, when it's reflected, looks like this. See, I've already done all that work, so all I have to do is go over here and do this. Okay? Now, we're going to make sure it's crooked, so I have to make sure it's right. 1, 2, 3, 1, 2, 3, yeah. Okay, now we're going to do the shrink factor of a half. All right, this was right 1, down 1. Well, if I multiply 1 by 1/2, I get a half. This right here was down 4, okay? Half of 4 is 2, so it went down 2. Right here, half of 9, I think it was, yeah, 3 down 9. Half of that would be 4.5. So this would be 1, 2, 3, 4.5 right here. Because these are symmetrical, it's going to be a half this way, 2 this way, and 3 right in here. This is the one I'm looking for. I actually could have even done 4, because 4 would have been right 4 down 16. The original one would have been to here. This one will be to here. Same thing over here. This would have been down 16, so half of it would have been 8. Okay. Again, I'm just using the transformations from 1.6. Okay, the domain, still all real numbers. The range, it starts down here at -infinity and goes up to 8. Now, these x-intercepts are nice because they actually are on a good point. So we don't have to do any work. All right. So this one would be 1, 0. This one here is 1, 2, 3, 4, 5, 6, -7, 0. And then the y is right here, and it is 1, 2, 3.5. But the problem with that is you need to make sure of that, or 3.5. But it's really easy, because here you would, if you had to have figured this out, you would have set your y equals to 0 and solve for x. Here you set your x equal to 0 and solve for your y, which means it's f of x equals -1/2 times 0 plus 3 squared plus 8. Okay, and when you work this out, this is going to give us 3 squared gives us 9 plus 8. Well, half of 9, oops, forgot my negative here. Okay, -1/2 times 9 gives us -9/2, or -4.5. Okay, this is the same thing as -4.5 plus 8. That's what's going to give us 3.5 or 3.5. So I just wanted to make sure that that is, because it looked like it. So, and if you'd have done all this, which you didn't have to, you would have found that we got the same thing. Again, you would plug in 0 for y and solve. Okay. General form. This is how I learned it. You need to know this. Your calculator will find all of these answers for you, but you need to know how to do this by hand. Okay, it's not difficult. You already know this formula, this part. Okay, it looks like the quadratic. The quadratic formula, we just used it earlier, I think. Hold on just a second. See this? This is the quadratic formula. Well, this part here is how you're going to find the x of your vertex. So, when it is in general form, okay, and depending on the book, sometimes I call it standard form, okay, to find your x value, you're just going to say x equals -b over 2a, that beginning part of that quadratic. Then, to find the y value, you plug this in. I'm going to do it like this, but this looks really hard, but all it does is says plug whatever your answer is to this into your function, it gives you your y. So right here, given this here, okay, we're going to, and then they talk about writing in standard form, which I usually don't, but it's okay. I'll do it because it tells us to, and I think maybe Pearson expects it. Okay, so what we're going to do is x equals -b over 2a. My b is 24. It's going to become a -24. And 2 times my a, which is -3. Guys, do not use your calculator yet. You can use your calculator, just don't do it at this point. Because if you don't plug it in right, it's going to be wrong. When I say that, I want you to simplify this first. If you need to use your calculator for 2 times -3, that's fine. But you'll have -24 over -6, which gives me a +4. What'll happen is sometimes you will do this. You'll say, this is how you'll plug this into your calculator, and it's wrong. -24 divided by, let's see if you can see this. I don't know if I can, there's a glare in here. Anyway, 2 times -3. Okay, when you do that, if I can get it so that you guys can see it. There we go. Close enough. Kind of blurry. You get 36. Because what you're telling the calculator to do is take -24 times, divide it by 2, which gives us -12, then multiply that by -3. That's where that gives it. Where here you have to simplify the bottom. We're really taking 24 and dividing it by the -24 divided by -6. Okay, so that's my x of my vertex. Now you take your x and you plug it back in here. You're going to say f of 4, which means just plug it in for x. -3 times 4 squared plus 24 times 4 minus 42. So I take out my x and I replace it with 4. When you do this on your calculator, it's going to give you 6. So your y is 6, your x is 4, and your y is 6. Okay, well, let's go over 4, up 6, 1, 2, 3, 4, 5, 6. Put your vertex, okay? Now, this, our A, is negative. So that tells me it's going to open down, okay? So I know it's going to go like this. Now, they tell you to rewrite this in standard form. That means we're going to put f of x, our A, which is the same, it's going to be -3. We use our vertex. In some books, they call this vertex form, okay? So you're going to say -3 times x, it's x minus whatever your x of your vertex is. In this case, it's 4, squared, then plus whatever your y is, okay? And now the reason they tell you to do this is so that you use your transformations, okay? This, of course, reflects it over the x, but that means it's going to open down. This is going to stretch your y by a factor of 3. This is going to move it right 4. This moves it up 6, but we've already taken care of that. Right 4, up 6. Okay. Usually, people are texting me, sorry. Okay. I put it on vibrate. Now, usually, what your point's going to be would be right 1, down 1, but because we have a stretch factor of 3, it would be right 1, down 3. Usually it'd be right 2, down 4, but because we're going to, instead of 4, you multiply that by 3 and you get 12. 5, 6, 7, 8, 9, 10, 11, 12, way down here. And that's all you have to do. And the reason is because you have this axis of symmetry. If you can get 1/2, you know the other half. This has an axis of symmetry of x equals 4. That's that vertical line, that imaginary vertical line. And the reason you want that is because if you got a point here, you're going to have a point here. If you have a point 2 to the right down there, you're going to have a point 2 to the left. All right, now we've got our parabola. Now, this one's not so nice. It doesn't cross at your x-axis, okay, not like at good numbers. So notice it says determine the exact x-intercepts algebraically. Same rule, okay? To find the x-intercepts, you put y equal to 0. So what I'm going to do, I'm just going to put my 0 on this side instead of in the front. And I think it's easiest to do it using this, okay? So, because otherwise you're going to have to use quadratic formula. -3 times x minus 4 squared plus 6. Okay, the way we did this before, I'm going to use a square root property because to me that's less work than quadratic formula. But you could use it. I'm going to take the 6 to the other side. -3 times x minus 4 squared equals -6. I'm going to divide by -3. And I get x minus 4 squared equals 2. Okay, now I need to take the square root. Because I'm taking the square root of both sides, this gives me x minus 4. Over here, I get plus or minus the square root of 2 because it wasn't there to begin with. Now I take the 4 to the other side by adding it. So I have 4 plus or minus the square root of 2. Now, what does this mean? This means that one of these x-intercepts is this, and the other one is this. Now notice, it asks for the exact, okay? This is the exact. We didn't use our calculator. Now, if you want to kind of look to see if that's where it should in your graph, you can say 4 plus square root of 2 in your calculator, and it becomes 5.4. Well, looking at our graph, 1, 2, 3, 4, 5, about 5.4. Okay, then if you want to do the minus to just check your graph, 2.6. 1, 2, it's not the best graph, but it's between 2 and 3, okay? If I was doing on a computer, it'd be better, okay? So, all right, now the y-intercept. Same rule as before, you take your x and set it equal to 0. So, I don't care where you put it. To me, it's easier here, and here's why. Wherever I see my x, I'm going to plug in a 0, which means this gives a 0, this gives me 0, and I'm left with negative 42. Hold on, I'm writing my work out, and then I'll move my paper back up. Okay, minus 42. Now, I don't need to write all this out because I can just look at it. That goes away, and when my x is 0, my y is negative 42. Obviously, it's way down here on the graph. Okay. Now, word problems. From here on out, anytime you see relative maximum and minimum, you're thinking vertex. Always vertex. Okay. Oh, by the way, it's okay. These are irrational, but it's okay to have those. Okay. Sometimes we may, by the way, imaginary things do not show up on your calculator. Okay, on quadratic functions, the absolute maximum and minimum values occur at the vertex. So anytime you read that, you think vertex, find the vertex. So for this function, determine its absolute maximum or minimum. Okay, well let's first of all, this is my a, it's negative. So that means I'm going to have, my parabola is going to look something like this. So that means it's going to be a maximum. Okay, well, if I ask for this, I don't want you to necessarily use, and you can check with your calculator, but I need to see this. Okay. You can use your calculator to do your calculations, but so my negative b, that's my b, over 2 times my a, which is negative 3 point, oops, let's try that again, negative 0.32. So again, only use your calculator in a minute. Don't use it yet. I mean, you can use it for this if you want, but it gives us negative 6.4. Now do the division. Okay, now do the 122.6, or negative, sorry, divided by 0.64, and you end up with this number right here, 191 point, let's do this to 4 decimal places. Because, well, actually, that's what it comes out to be, 4 decimal places. Okay, that is your x value. That is your first value. I need to know what my y is. Well, all you have to do is plug it in. So you take this and you plug it in here and here. You are then going to, so here's what you're going to do. Plug it in. So you're going to say f of 191.5625. So here's what I'm going to do. I already have that in my calculator. I'm going to store it under X. And then I'm going to plug it in. I'm going to say negative 0.32 x squared plus 122.6x minus 13.6. And I get that great big number. Okay? I get 11,729.1825. So that would be my y value. I don't like to use my comma here because I don't know which one's for my point. It gets confusing. And I don't have enough room. Okay, so this is our max. Our maximum occurs there. Okay, now, if we wanted to check this answer, sometimes this works, sometimes it doesn't. Depends on, you have to play with your settings on your calculator. Sometimes it's too big. So you go to y equals, I'm going to clear all this out, and I'm going to plug this in, negative 0.32 x squared plus 122.6x minus 13.6. I'm going to zoom 6. I don't know what it's going to look like. Probably isn't. No, I know it's not going to be on here. Part of it is, but you can't see it because it's huge. Okay, I think it's going to be too big myself because I can't even get it to show up. All right, but second calc, and you can find your maximum. You'd have to put it on the left side, put it on the right side, put it in the middle, and this would pop up, but I think this is going to be too big. I don't even know how you'd get it on the right side because you have to go out to 191. I guess if I played with it enough, but I don't want to. I know this answer's right, so I'm not worried about it. Okay, I did not, these are not my notes because here's the thing, the quarterback doesn't snap. He throws, or he passes. Okay. All right. Things like that bother me. A quarterback throws to a receiver, and the function this models the pass, where X represents the number of horizontal yards from the quarterback the ball has traveled, and Y is our output, represents the height of the ball in feet. Find the vertex for this quadratic function. Okay, so let's first draw our picture. Okay. We got our quarterback right here. There's my great stick figure. Okay. We got a receiver somewhere down here. He throws the ball and it looks like this, right? All right, so let's say we are receivers right here. Okay. X is our yards, our horizontal yards. Y is the height of the football in feet. Okay, so this is how far they are from the quarterback, and then this is how high the ball has traveled. Find the vertex. Okay, it's got a maximum, so it's up here, the height of the ball. Okay, you'll see this with a kicker punting a ball, somebody hitting a baseball, the flight of the baseball off the bat, things like that. A rocket being shot up in the air and coming back down. Okay, so we're going to still do it the exact same way as we did it before. To find our x, it's negative b over 2a. Our b in this case is 2.1, so it's negative 2.1 over 2 times our a, which is negative 0.04. So we have negative 2.1 over negative 0.08. Sorry, I left out that 0 in front of it, but I don't care because it's going to do the same thing. And when I do that, oops, hold on just a second. I have to get out of where I was at. Negative 2.1 divided by negative 0.08, and I get 26.25. Okay, now think about this. X is my yards from the quarterback. It says that represents the number of yards from the quarterback. Okay, so this is in yards. The Y, because we got to find the Y, we just got to plug this in. we got to say f of 26.25. So what we do is we take this and we plug it in here. So I already have it in my calculator. I'm going to store it under x, and then I'm going to say negative 0.04 x squared plus 2.1 x plus 6.1. And it comes up to be this number here, 33.6625. 33.6625. That is my y. It represents the height of the ball in feet. So my vertex is at 26.25, 33.6625. Now, why would you ever need anything like this, even if you weren't in sports? But let's say you were building a gym, okay? Kids who, or people who shoot, shooting a basketball, it has an arc on it. Well, if you're building a gym, you need to know how high people's shots are so that you can build the roof and the walls high enough so that the ball doesn't hit the ceiling. That's just one, same thing with indoor football stadiums. When the punter punts, you need to know how high the maximum height they're going to kick it so that you can build it up high enough. Okay, so now they go to the questions. This is asking to interpret what you found. What is the maximum height the ball reaches? Well, remember the height is our y. Well, the maximum was the 33.6625 feet. And how far down the field does this occur? Well, that was this 26.25 yards. Okay. Now, and that you can put downfield if you want. It doesn't really matter. Okay. All right. What happens if the receiver misses the pass? How far downfield does it land? Well, let's say it hits the guy's hand and it lands right here. Its height is 0. So what you're going to do is you're going to now plug in 0 right here. Okay. And you're going to have equals negative 0.04 x squared plus 2.1x plus 6.1. Well, I can tell you right now, my favorite way of solving these problems is factoring, but I don't know how to factor this. So I have to use quadratic formula. X equals negative b, so it's going to be negative 2.1 plus or minus the square root of b squared, which means 2.1 squared, minus 4 times my a, which is 0.04, times my c, which is 6.1. All over 2 times my a, which is negative 0.04. Okay. Now, I've cheated. I've already got this because I've worked this problem before. This is negative 2.1 plus or minus. This in here is going to give me 5.386. All over 2 times this gives us a negative 0.08. So when you do that, when you do the 2.1, let me move this up, the negative 2.1 plus this, get that answer and then divide by this. One of these answers will give us 55.3 yards. And then one of them, when you do the minus, I don't know which one's which, okay? I'm thinking the plus is this one maybe. And then when you do the minus one, it'll give you a negative 2.8 yards. But that doesn't make any sense because we threw it downfield. This would be behind him, okay? So that would not make sense. So we kick that out, and this is our only answer. Okay, one last word problem. You have to enclose 1,200 feet of fencing to, I'm sorry, let's try this again. You have 1,200 feet of fencing to enclose a rectangular pen next to a straight river. There will be 2 dividing walls in the enclosure to make equal sized spaces. Create a function modeling the enclosed area in terms of x. Okay, so we have 1,200 feet to put fence along all of these dark lines here. This river, apparently whatever we're going to enclose, if it's animals, hopefully they don't swim. Okay, so we've got 2 things going on. So we have this one length, and we have 4 of these that are the same width, or I'm sorry, the same length and width. Usually width goes across. I always think of length being the longer side. So anyway, we do know that we have 4 of these plus this y. We've used 1,200 feet of fencing. Okay, so this is our fixed relationship because we need to eliminate one of our variables. We got to get everything in terms of one variable. So right now, and seeing we're trying to get it in terms of x, what we want to do is get rid of our y. So I'm going to solve for y on this problem, and I get y equals 1,200 minus 4x, because I'm going to take the 4x to the other side. Okay, so now it says area. Well, area of a rectangle is length times width. In this particular case, we are going to say, we're going to call it a of x because we want it in terms of x, equals our length, which is x, and our width, which is y. So we're going to have x times y. You could have y times x, it doesn't matter. All right, so that's what we're trying to find. Well, remember we have our fixed relationship right here. I can now take out my y and replace it with this. 1,200 minus 4x. Because this is our perimeter. This is how much of the fence we use. Well, we want to know the area, which means it's all of this in here. Perimeter is the outsides, okay, and plus this. Okay, think of that. Okay, it's not really not perimeter, but it's how much fence we use, which are these lines. Well, we're trying to find, like, let's say the grassed area. Okay, so we just found our formula right here. Or we can do this. We can simplify it. This gives me 1,200x minus 4x squared. Now, we could put this in the right order. So our x would be a of x gives us negative 4x squared plus 1,200x. Okay, so now we've created our function. Okay, x is our input, which is our width. Okay, actually it doesn't really matter. Now I've gone back to it. Okay, it's these. Okay, now because again I always think of length being my longer side. So but be careful. Our a of x is our output. Now our output is the area of the enclosure. It's not our length, okay? Not length, because that's where it gets confusing sometimes, okay? The A stands for our area. All right, find the vertex of the quadratic, okay? Well, we're going to do the same thing. X equals negative b over 2a. So we have negative b, which is 1,200, over 2 times our a, which is negative 4. This is negative 1200 divided by negative 8. When you divide that out, you get 150 feet of width. Okay, that's our how wide it is. That's our x's. So each one of these is 150 feet. Okay, to find our y, that is our a of x, that's our output. Okay, we're just going to plug this 150 into our formula. Negative 4 times 150 squared plus 1200 times 150. And when you do that, we're going to end up with 90,000, and area is in square feet. So you represent that as square feet. Sorry, couldn't see that. Okay. And that is the largest enclosure, or the largest area that we can make out of this 1,200 feet of fencing. Okay, so what is the maximum enclosed area? That's at 90,000 feet. I'm sorry, square feet. That's area. All right, well, what should the dimensions of the rectangle be to get the most out of the area? Well, we know what the width is. We know the width is 150 feet. Okay, we've got to find our length. So there's actually a couple ways to find the length. Okay, one way is up above, we found that y was equal to, our function was this here. Remember? Okay, we have our x, which was our w. Okay, now here we need to find that. So all we have to do is say 1200 minus 4 times 150, and you're going to get 600 feet. Okay, so what that means is each of these is 150 feet, and this one's 600 feet. Now, that's one way. The other way you could have just done it is you could have said 90,000 divided by 150, because remember, area is length times width, and it's still going to give you that, not 600 feet. Okay, now, so the rectangle, because it says what should the dimensions be of the rectangle? The rectangle is 150 by 600 feet. Okay, now just so you know, if you did 150 times 600, that gives us our 90,000 square feet. That's our area. And then if we did 600 plus our 4 times 150, that's our perimeter, that's the number, that's our fencing, and it was 1,200. Okay, that finishes up 2.2.